yesterday we learned how to write logs in right from log form to exponential form, and then exponential form to log form. We toggled back and forth, okay? Now we're doing something called evaluating. So your directions, JT, your directions, you should be not on your laptop while I'm teaching. You're going to see in the directions the word evaluate. What that means is solve, okay? Fancy word for solve. You're going to be solving some equations. And guess what? You all just did it on the most recent test. Okay, exactly what we're about to do with one extra step. So here are the two steps when you have to evaluate. You set the expression, now let's go back to that word in a second, equal to x, or really any variable you want. X is usually what we use. Now an expression, look down below at those. Those are expressions. They don't have an equal sign in it, okay? If it has an equal sign in it, what would it be called? An equation. Yeah, Raja. Come on, take a note. So you're going to set it equal to x and make it an equation. You're going to make it to be an equation. And then you rewrite it in its other form. I think I told you guys yesterday that that's going to be part of the directions a lot. Rewrite it in its other form. So if it's currently in log form, you'll write it in exponential form. If it's in exponential form and I say rewrite it in its other form, you would write it in log form. So if you weren't here yesterday, this is really Sarah who's listening right now, what we learned yesterday was if you're given a log, the way you would read this is log base 7 of 49 equals x. That is log form. It has the word log in it. To write it in its exponential form, we start with the base to the power of x. Remember, the loner on the other side of the equation is a loner in the equation. So 7 to the power of x equals 49. So that's step 1 in solving log functions. Rewrite your log in exponential form. And then, guess what, guys? You've already done problems like this, which I'm going to show you here in a second. What we want to do with all of the equations, and you're going to be able to with all of them that I gave you today, is get like bases, just like you did on the test. Okay? So, let's do 3 examples. Let me give you a second to catch up in case you're not there. Okay, so the first step, as I said, is to set the expression equal to x. So here's step 1. Watch, because if you blink, you'll miss it. Equals x. Okay, make it an equation. Our expression became an equation. And now it's set up to solve the same, or to rewrite it just like we did here. Base of 216 to the power of x, I should have finished it, equals 49, equals 6. So that's 216 to the power of x equals 6. Does it matter where the numbers and letters go? Yes. And what base should we try to make a 216 into? A 4, a 2, a what? Who got a really high grade? Alessi. Oh, is she not here? Who else got a high grade on this test? What should we try to make 216 have a base of? Dylan! 6. Where'd you get 6 from? You're right. What made you think of 6? Because that's what's on this side, right? This is 6 to the power of 1, right? Let's see if we can make 216 into a base 6 as well. Which of course we can, guys. I'm not going to give you one that you can't yet. So 6 to the power of 3. Is that 216? It is. I knew it wasn't 6 squared because 6 squared was 36. 6 to the... Whatever. There. 6 to the power of 6. I'm almost going to get my old calculator back out here because this one is not showing up well. Okay, so 6 to the power of 3, that's 216. Remember, if there's already a power there, it hangs out or multiplies. 3 times x. equals 6 to the power of 1. What do we do next? If the bases equal each other, the exponents equal each other. And the answer is 1/3. You just solved your first log equation. So we use exponential tricks to solve log equations. Okay, let's do B. First step, set it equal to x. Make it look like an equation. You can pick whatever letter you like. You can choose all 26, pick an alphabet from another language. It doesn't matter. Daniel, what language do we use in our class? What language of the alphabet? Instead of, whose alphabet do we use? We use the Greek alphabet. That's what we use. Theta. Okay, so starting with base 3 to the power of x equals this. So that's step 2. Rewrite your log in the other form. So that's 3 to the x equals 729. Somebody besides Dylan, what base should we try to make 729? 3, right? I don't know what it is. I truly don't. I mean, I have a key, but I wouldn't know that otherwise. I would have to pick up my calculator and try different numbers. Now, I'm not going to waste my time starting with like 3 to the 3rd power. I'm trying to make this easy to it. Like 3 to the 3rd power. I know that one. I use it all the time. Let's go higher than that. 3 to the 4th power, 81. Nope, we're pretty far away, aren't we? 3 to the 5th. 3 to the 6th. This is easy. I'm just hitting buttons on my calculator. I'm not having to do any math on my own. And there it is. 3 to the 6th power is 729. So I have 3 to the x equals 3 to the 6th. If the bases equal to each other, so do the powers. Set them equal to each other, and there's no other work to do. X equals 6. Now, something I did not teach you guys yesterday. There's something called, and if you want to put it on your notes, maybe I should have written it up here. There's something in logs called a common log. And what it is log base 10 is just written as log. We don't put the base there. So when you see a log like this, where's that little subscript number? When you don't see one there, it goes automatically to a 10. It's kind of like when you see an X, none of you are wondering what number's in front of it. You know that that's 1x. We just don't put the 1 in front of it. Same with x equals x to the power of 1. We don't write it. We just know it's a power of 1. Okay? So whenever you see a log without a base, it means base 10. Sometimes it's written there. Sometimes it isn't. It's okay if you put it there. It's okay if you leave it off. Okay? Kind of like these situations. Right? The rest of this is the same. Equals x. There's step 1. So that would be 10 to the power of x equals 0.001. Now, decimals. Oh my gosh, why is she giving us ones with decimals? The other ones were so easy. I was understanding those, and now she's going to change it up. I'm going to ask you guys the same question I asked you on A and B. What base should we try to make this? Think of the same way you answered the last few questions. In example A, we said, oh, we're going to try 6. In example B, we're going to try 3. What should we try? Stick with the same thought process. What would we try? 10. Yes. Well, you know 10 to the first is 10. 10 to the second is 100, right? We're going in the wrong direction. Okay? I could do 10 to any number. I'm going to still get bigger numbers, right? Unless I do what? What can I do instead of positive numbers? Yeah. So 10 to the negative. I don't know all the answers. I'm going to put them in my calculator. I'm going to keep going till I get to the answer I want. Do you see how we're getting closer and closer? 0.001, there it is. You can have a negative exponent. It's fine. Totally fine. Okay? So 10 to the x equals 10 to the negative 3.
OSP is negative 3?
What, Evan? Or was it Dylan? Which one of you? Yeah, okay. All right, so we don't just quit on a decimal or just copy my answer. Think about it. I gave you one in your homework that's got a decimal or something like that, okay? Good? 13 through 23. Same paper you were on yesterday. Same paper you were on yesterday. So these are the answers. These are not the work. If I check this homework, I will want to see the actual setting up of the problem. So you probably can't fit it on here. It's up to you. Maybe you can do it in the margins or something. Follow the same steps that we did. We'll have our homework check after I let you work for a little bit. So I can answer questions. It's not from anything the last couple days, so you should be fine. Did we finish our homework in class? There's no reason for you guys not to be finishing your homework. Usually it's because you can't find it. That's the problem.